questions 11 through 20 on the 2017 grade 12 AMC 12B. Call a positive integer monotonous if it is a one-digit number, or its digits, when read from left to right, form either a strictly increasing or strictly decreasing sequence. For example, 3, 2, 3, 5, 7, 8, and 9, 8, 7, 6, 2, 0 are monotonous, but 88, 7, 3, 7, 4, 3, 4, and 2, 3, 5, 5, 7 are not. How many monotonous positive integers are there? There's two categories. The first is when they are increasing, and of course the second category is when they are decreasing. The numbers, that is. So we line up the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and obviously this is one such example. Now here's a really cool way of thinking about this question. We can either include or exclude each of these numbers, and when we do, it will still create an increasing number, and therefore monotonous. So for example, if I got rid of that, it's still a monotonous number. If I got rid of the 3 and the 5, it still works. If I got rid of that, it still works. You see what I'm saying? So all we have to do is decide whether we're going to include or exclude. The 1 can be either included or excluded, so I have two possible choices for the 1. Similarly, I have two possible choices for the 2, and so on. Either I can include or exclude. So then what I do is I multiply them all to get the number of different combinations, and that is just simply 2 to the power of 9. But here's where it gets tricky. Not extremely tricky, but just a little bit. That one of these I have to subtract. Why? That is the one where all of them are excluded. If I excluded all the numbers, I'd have an empty set. And an empty set obviously is not a number. And that's one possible outcome. So that one possible outcome I have to subtract from the total. And when you do, you get, 512 minus 1? So 511. Now if they're decreasing, let's line up the numbers. 9, 8, 7, 6, 5, 4, 3, 2, 1. But we can also include the 0 in there. And as before, we can either include a number or we can exclude a number. So in a very similar way, we got two choices for each number. We either include it or exclude it. And then, of course, we have to multiply them all. When we do, we get basically 2 to the power of 10. Now, as before, we have to think about anything that I need to subtract from this 2 to the power of 10 number. And the answer is yes. As before, if you exclude all, that's going to be an empty set. So that one possible outcome needs to be subtracted. But there's another one in this one. If you include only the 0, you excluded everything, but you included the 0. That doesn't work. Why? Because it has to be a positive integer. And 0 is not positive, so I got to subtract that one also. So this is 1024 minus 2, so 1022. So I got this and I've got this. Okay. 511 plus 1022. Well, that is equal to 1533. And that is one of the answer choices. But we still have to subtract something. So it's not that simple. In part 1, we included all the single digits, all the one-digit numbers. Some of those outcomes would be 1 or 2 or 3 or 4 and so on. And for example, if you excluded everything but kept the 1, it would give you a 1. If you excluded everything but kept the 2, included the 2, it would give you a 2. Very similarly, in the decreasing, it also ends up in a way that you can produce the same one-digit numbers. So we've double counted those, and since there's 9 of them, we have to subtract 9 from the total. So now finally we get the actual final number, which is 1524. And therefore number 11, the answer is B. What is the sum of the roots of z to the 12th is equal to 64 that have a positive real part? Well, z is obviously a complex number of the form a plus bi, and this is the real part, this is the complex part. They want a positive real part, so they want this part to be positive, so obviously a's got to be greater than 0. Okay, well, I will show you what I think is a very nice way of approaching this question, less confusing, is you put it on a standard circle. So here we go. And when you put it on a circle, each of these roots are going to be spread equally. So we're going to have, for example, one root that ends up here, one root that ends up here, 30 degrees, right? There's 12, so they're going to be equally spaced around the circle, and so on, all the way around. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now the good news is that we don't have to actually figure out all of them. We just have to figure out the ones that have a real part that is positive. So that's the x-axis, the real axis, and this is the imaginary axis. So we only have to be concerned with these guys here. Those are the only ones that have a positive real part. Okay, well, let's figure them out. Z to the power of 12 is 64. So just looking at the real part, 164 to the 1/12 is z, and that's root 2. So that immediately tells me that this is root 2. Now the rest of them, this one, this one, this one, and this one, those ones have imaginary components. Well, the good news is, in this particular diagram, I can figure that out using the 30, 60, 90 triangles. And they're basically going to be the same on the other sides. So from there to there is root 2, so from here to here is root 2. And therefore, this x component, or x coordinate, can be calculated with the 30, 60, 90 triangle. This is 30, this is 90, this is 60. So if this is xy, then this is x, and x over root 2, which is the hypotenuse, is, if you remember, root 3 over 2. And therefore x is root 6 over 2. And therefore this is also root 6 over 2, since it has the same x coordinate. And that's going to be minus y. So this is going to be root 6 over 2 plus y. And that's going to be root 6 over 2 minus y. In a very similar way, we can figure out this guy. That one, if that has an x coordinate, again, this is going to be now 30. And this angle is 60. So x over root 2 again. This time this is x. And of course this is root 2. Is the same as 1 over 2. So x is root 2 over 2. So this is root 2 over 2. And this is some y. And this guy here is root 2 over 2, negative y. And now we have to add up these 5. Well, the good news is that when you add up the 5, the imaginary parts cancel. This y cancels with this negative y, this y cancels with that negative y. And then this one just had 0 for its imaginary parts, so there's nothing to add there. So now we just have to add the x coordinates. So root 2 over 2 plus root 6 over 2 plus root 2 plus root 6 over 2 plus root 2 over 2. And when you add all those up, you get 2 root 2 plus root 6. And therefore, number 12, the answer is D. In the figure below, 3 of the discs are to be painted blue, 2 are to be painted red, and 1 is to be painted green. 2 paintings that can be obtained from one another by rotation or a reflection of the entire figure are considered the same. How many different paintings are possible? Well, here you go. These are the possibles. these are the different types of, I guess, arrangements. And none of these are duplicates because they made sure to tell you that if you can get something by rotating or reflecting, it's considered the same. So these are unique. And as you can see, they labeled G, R, R, and therefore, obviously, the ones that are not labeled are the blue ones. And, of course, counting, there's 12 of them. So I encourage you to kind of fiddle around with this and figure out a quick way of sort of listing these types of arrangements. Number 13, therefore, the answer is D. An ice cream novelty shop consists of a cup. Ice cream novelty item consists of a cup in the shape of a 4-inch tall frustum of a right circular cone with a 2-inch diameter base at the bottom and a 4-inch diameter base at the top, packed solid with ice cream, together with a solid cone of ice cream with height 4 inches, whose base at the bottom is at the top base of the frustum. What is the total volume of ice cream in cubic inches? All right, so we've got to figure out what this looks like. Okay, so I think it looks something like this. And let me explain all of these dimensions. So this novelty item is in the shape of a 4-inch tall frustum. So a frustum is basically this part right here. When you take a cone and then you chop off sort of this part, what's left is the frustum. So we have this part right here, that part. And then they told me that the diameter is 2 inches at the base, so this is 2 inches from here to here. Let's put that there, 2. And then 4 inches at the, and a 4-inch diameter base at the top. So this is 4, the distance from there to there. And then they tell me that the together with a solid cone of ice cream of height 4, so they've got a cone sort of sitting on top, and that's got a height of 4. All right, and now they want you to figure out the volume of this whole thing. So basically what we have to do is figure out the volume of the top and then just this frustum. All right, so that shouldn't be too hard. The volume of the top, it's a cone, so it's going to be 1/3 pi r squared times height. And then the frustum you get by taking the full cone and then subtracting from it the small cone. So that's going to be pi, I'll just call it big R squared. I'll just call these t for the top, radius of the top and the height of the top. So 1/3 pi r squared minus 1/3 pi r small r squared, and then we got to put in the heights h and big H. Okay. All right, so a lot of this we can factor out the pi over 3, and then let's see what we know so far. The radius of the top is 2, and then the height, they told me, is 4. So that's pretty straightforward right there. So that's 2 squared times 4. And then this part here, the big R is 2 again, and then the height of the whole thing from top to bottom, that we don't know yet. So I'll just put that H for now. And then this one, that small r, we know since that is 2, the r is 1. And then the small height we don't know yet. Okay, so now we've got to chase after these heights. So let's draw a line from the bottom to the top, and I think we're going to use some little triangles. So this from here to here is 1, and I'll call from here to here small h. And the frustum is 4 inches tall, so from there to there is 4. And then from here to here, that's 2, since it's half of the diameter. Okay, from similar triangles, we have that 2 over 4 plus h is equivalent to 1 over h. Cross multiplying, get 2h is equal to 4 plus h, and therefore h is equal to 4. Great. So that means the big height, which would be all the way from there to there, would be 4 plus h, and that is 8. All right, we have all the numbers now. So we got pi over 3. This is going to be 4 times 4 is 16, plus 4 times big H. H is 8, so 4 times 8 is 32. And then minus h times 1, which is 4. So this becomes 44 pi over 3. And therefore, number 14, the answer is E. Let ABC be an equilateral triangle. Extend AB beyond B to a point B prime so that B prime B is 3AB. Similarly, extend BC beyond C to point C prime so that C prime is 3BC. And extend side CA beyond A to point A so that A prime is equal to 3CA. What is the ratio of the area of triangle A prime, B prime, C prime to the triangle ABC? Okay, let's draw this. So, I've got an equilateral triangle, and I've got to draw it in a way so that when I extend it like that, that has a ratio of 3 to 1. So if this is x, this has got to be 3x, that length. And then once I do that, I do it to all 3 sides. So I do it here also, and I do it to here also. And let's join all of this now. There we go. And then this is, of course, needing to be labeled. A, B, C, and B was extended to B prime, C was extended to C prime, and A was extended to A prime. So now I have to figure out the ratio of A, B, C, all prime to A, B, C. Okay. Well, the ratios will be fairly straightforward. All we have to do to make this question quicker is just get the ratio of the square of the sides, because these are areas, and if you just take the square of the sides, that would be sufficient. So if I call this, let's say, S, and this side I've labeled X, really all I have to do is find S squared over X squared, and that will give me my ratio. Okay. Well, what is S? Well, this is X, this is X. It's an equilateral triangle. So therefore, this is 3x. And since it's equilateral, that's 60 degrees. So therefore, this angle is 120 degrees. So I can use law of cosines to find S. S squared will be 4x squared plus 3x squared minus 2 times 3x times 4x times the cos of 120. So S squared will be, what's that, 16 plus 9, 25x squared. And then this is 12x squared. And the cos of 120 is negative 0.5. So that looks like 12 plus 25, 37x squared, S squared. So S is root 37 over x. Okay, well, let's go back to here. S squared, that was 37x squared over x squared, and then x squareds cancel, so we just get 37 over 1. And therefore, number 15, the answer is C. The number 21 factorial is equal to this, and has over 60,000 positive integer divisors. One of them is chosen at random. What is the probability that it is odd? Well, let's look at all the numbers from 21 down to 1. And let's break up each into its prime factors. So 3 times 7, 2 times 2 times 5, that's just 19. That's going to be 2 times 3 times 3, that's just 17. This is 2 times 2 times 2 times 2. 15 is 3 times 5, 14 is 2 times 7, 13 is prime. This is 2 times 2 times 3, 11 is prime. 2 times 5 and 3 times 3, 2 times 2 times 2, 7, 2 times 3, 5, 2 times 2, and 3, 2, 1. Okay, now let's break up 21 factorial into its prime factorization. So, 2, I've got to count them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, great. The next one is 3. I've got to count those. 3, 1, let's see here, 2, 3, 4, 5, 6, 7, 8, 9. 9 for the exponent for 3. Now the next prime factor is 5. 5 will be 1, 2, 3, 4, and I think that's it. So 4. 7 is the next prime factor. I think we have 1, 2, and 3 for that. And I think after that, we just have individual primes. So 11 only appears once, 13 only appears once, 17 once, and then 19 once. Okay, now to figure out the number of divisors, you would do the following. 18 plus 1 times 9 plus 1. Then the next one is 4 plus 1. The next one is 3 plus 1, and so on. And then the last ones would give you 1 plus 1, 1 plus 1, 1 plus 1, and 1 plus 1. So when you multiply all this out, this is the number of divisors. That's a quick formula. When you multiply this number out, you get 60800, and that is indeed what they're saying. It's over 60,000 positive divisors. Now what they're saying is one of those divisors is chosen at random. What is the probability that it is odd? The only way one of the divisors will be odd is if it does not include the 2 to the power of 18 or any of its divisors, because that's the only even number in there. So if we exclude that and just look at these guys, nothing in there will be even. They will all be odd, any such combination. Okay, well those guys are just 9 plus 1, 4 plus 1, 3 plus 1 in terms of the number, and then these 4 1 plus 1s. These are the ones. These are the divisors that do not include the 2 to the power of 18 or any of its divisors. Just these guys and its divisors. Well, the probability, therefore, would be that over the total. And the total is 18 plus 1, and then all the other guys, 9 plus 1, and so on. And the cool thing is that everything cancels. The only thing that doesn't cancel is this 18 plus 1. So the probability ends up being just 1 over 18 plus 1, which is 19. So number 16, the answer is B. A coin is biased in such a way that on each toss the probability of heads is 2/3 and the probability of tails is 1/3. The outcomes of the tosses are independent. A player has the choice of playing game A or game B. In game A, she tosses the coin 3 times and wins if all 3 outcomes are the same. In game B, she tosses the coin 4 times and wins if both the outcomes of the first and second tosses are the same, and the outcomes of the third and fourth tosses are the same. How do the chances of winning game A compare to the chances of winning game B? All right, so let's figure this out. Heads has a probability of 2 over 3. Tails, probability is 1/3. We have game A and game B. We have 3, rounds that we're doing this in, 3 tosses. So she wins, or whoever is playing the game, if you get all 3 the same. So either heads, 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 or tails, tails, tails. That's one way of winning the game. Another way of winning the game that's in game B is if you get the first 2 the same, and game B has 4 tosses, the first 2 have to be the same, and the last 2 have to be the same. So it can be either HHHH or HHTT, or it could be TTHH, or it could be TTTT. So that is basically the scenarios. Then we got to figure out the probability for each of these. It shouldn't be too hard. Okay, 3 H's in a row. Each H has a probability of 2/3, so 2/3 to the power of 3. And then we have to add the probability of winning in that sort of format. That would be 1/3 to the power of 3. So this is 8 plus 1 over 27. So that's 9 over 27, which is 1/3. So the probability of winning game A is 1/3. Okay, now we got a little bit more work to do for game B. For this guy, it looks like 2/3 to the power of 4. Plus 2/3 to the power of 2 times 1/3 to the power of 2, right? And then that one, it would be 2/3, same thing actually, 1/3 to the power of 2, 2/3 to the power of 2, and then the last one would of course just be 1/3 to the power of 4. All right, let's add up these guys now. So we have 16 over 81, and then plus 4 over 81 plus 4 over 81 plus 1 over 81. And that is 25 over 81. All right, so that's the probability of winning game B. So we have to compare 1/3 to 25 over 81. 1/3 is obviously bigger, I believe, not by much, but it's bigger. It's right here. If I use the common denominator, we would multiply this by, it would be 27 over 81. Yeah. So yeah, game A has a higher probability of winning. The difference, of course, 27 over 81, 25 over 81, that difference is just 2 over 81. So game A has a higher probability of winning by a difference of 2 over 81. So let's see what the answer choices are. The probability of winning game A is 2 over 81 greater than the probability of winning game B. Yeah, that matches our findings. So number 17, the answer is D. The diameter AB of a circle of radius 2 is extended to a point D outside the circle so that BD is 3. Point E is chosen so that ED is 5, and line ED is perpendicular to AD. Segment AE intersects the circle at point C. Between AE, what is the area of ABC? Okay, let's draw this graph, or this diagram, I should say. And let's draw the diameter AB. Let's extend it a little bit more. And then we have to draw a perpendicular line that's about 5 approximately. So that's about 5. And then we have to connect that one. So I think that's pretty much the diagram. Now let's label this. So we've got A here, B here. Has a radius of 2. So I guess this is 2 and that's 2. B is extended to D, so that BD is 3, so that's 3. And then ED, this is E, and therefore this is 5. It's at a perpendicular. And what do they want me to figure out? The area of ABC, and C is this point where it intersects a circle. Okay, so I obviously have to connect C to B. And because ACB is part of a semicircle, that is a right angle. So that's going to help us a lot. So the area of ABC would be just 1/2 base times height. We can use BC and we can use AC. All right, so I guess first I have to figure out the values of AC and BC. Okay, well, the first thing, I think using Pythagoras, I can easily figure out AE. That's just going to be 5 squared plus 2, 2, and 3 is 7 squared. So that's 25 plus 49, 74. And therefore, AE is root 74. And I think the other guys I get using similar triangles. So that would be Let's give some angles here. This is theta. This would be 90 minus theta. And this is 90 minus theta as well. So obviously this triangle is similar to the big guy because they have the exact same angles. Okay, that helps. Triangle ABC is similar to triangle ADE. All right, so that means AB over AC is equal to AE over AD. And that means 4 over AC is equal to root 74 over AD, which is 7. So solving, I get AC is equal to 28 over root 74. And in a very similar way, I can figure out BC using the same two similar triangles. BC over AB is ED over AE. So that means BC solving, well, we know all these, right? BC, AB is 4, ED is 5, AE is root 74. So that means BC is 20 over root 74. All right. Well, we'll go back to this formula and figure out the area. So that's going to be 1/2 base times height. BC is 20 over root 74. AC is 28 over root 74. So it looks like 20 divided by 2 is 10. 10 times 28 is 280. And the root 74s become 74. And in lowest terms, 140 over 37. Number 18, therefore, is D. Let n be equal to this big long number, which is a 79-digit number that is formed by writing the integers 1 to 44 in order, one after the other. What is the remainder when n is divided by 45? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then 11, then 12, then 13, then 14, and so on until 43, 44. Well, they want us to divide that big long number by 45 and figure out what is the remainder. All right. Well, 45 is 9 times 5. So I'm going to work with 9 and 5 individually. First, what I'm going to do is look at the 5. Is this divisible by 5? And the answer is no, because that last digit is a 4. The last digit has to be either a 0 or a 5 to be divisible by 5. Well, if I take that 44 and subtract from it 9, that will end up with 35. And that will be divisible by 5 because it ends in a 5. So that means that this n minus 9, it was the big long number, I just wrote the 44. N minus 9 is divisible by 5 because it has 5 as the units digit. All right, so that's actually the easy part. Figuring out that was simple. Now we got to turn our attention to the more challenging one, which is 9. The last digit is not going to be that simple here. We're not going to be able to do this system. So we have to use a different system. And that is as follows. If the sum of the digits of n, I should say, if the sum of the digits of n are divisible by 9, that will prove that n is divisible by 9. All right, so let's see. Let's figure out the sum of the digits of n. Okay, well, obviously 1 plus 2 plus 3 plus 4 plus 5, all that stuff, right? All the way till 9. But then we get to 10, 11, 12, and each of those also have the same units digits, as do 20 to 29 and 30 to 39. So this string appears 4 times. And then for the 10s, each of those 10s gives you a 1, right? You have to add it like that. Each of those gives a 1, so you have to add 10 of those. And each of the 20 to 29 would give you a 2, so you have to add 2 10 times. And each of the 30 to 39 gives you a 3. And then you've got the final ones, 40, which is just 4 plus 0, 41, which is 4 plus 1, 42, which is 4 plus 2, 43, which is 4 plus 3, and finally the 44, which is 4 plus 4. When you add up all this, it's 180 plus 10 plus 20 plus 30 plus 30, and that's 270. And 270 is indeed divisible by 9. So that means, that proves that n is divisible by 9, since this was the rule. Okay, so if n is divisible by 9, that means n minus 9 is also divisible by 9, right? If you subtract a 9, it will still be divisible by 9. So therefore, we have concluded that n minus 9 is divisible by 5, and n minus 9 is divisible by 9. So therefore, n minus 9 is divisible by 9 times 5, which is 45. So n minus 9 is divisible by 5, so therefore n would, when divided by 45, would give a remainder of 9, since 9 is what would be left over from the value n. Interesting question. Number 19, the answer is C. Real numbers x and y are chosen independently and uniformly at random from the interval 0, 1. What is the probability that the log of x to the base 2 bracket is equal to the log of y to the base 2 bracket, where bracket r denotes the greatest integer less than or equal to the real number r? All right, so let's make a little table. Okay, well, we are going to choose values anywhere between 0 and 1. And when we do, whatever we choose, that has to basically fit into these guys here. So let's start with the biggest one, 1, and let's see what happens. If I chose x to be 1, then I would have a situation as follows: log of 1 to the base 2. And log of 1 to the base 2 is 0, correct? So the values of log of x to the base 2 bracket, it seems like it starts off with 0, and then of course it will differ for different values. And this happens, first we have to fill in the table's contents. This is x, y, and this is going to be the probability. So this happens when x is 1, and we want log of x to the base 2 equal to the log of y to the base 2 bracket. So we want that to be 0 also. Well, that's got to mean that y has to be 1. All right, so far so good. Hopefully haven't lost anybody yet. Now we got to keep going here. I'm going to go to -1. Why -1? Well, because they've put this bracket in here, so that means these values are always just going to be integers. You see what I'm saying? They're not going to be like point something. Even if they are, if the value inside is point something, we've got to take the integer value that's the greatest integer less than or equal to. So that's why we can only go down by integers. -1, -2, -3, and so on. Okay. If the log of 2 to the x is -1, that happens when x is obviously between some range. It's got to be less than 1, but it's got to be greater than a half. And obviously it has to be less than 1, but let's figure out why it's got to be greater than or equal to half. Let's say x was a half. Then you'd have the log of a half to the base 2, which is 2 to the -1 to the base 2. Put the -1 out front, you get log of 2 to the base 2, and this is just 1, right? So that's how you get -1. And then similarly, if it's anywhere in that range, when you take this special bracket of it, it would drop the value to -1. Greatest integer less than or equal to the real number. And similarly, y's got to be the same. So y's got to be in the same range. Now, let's figure out the probabilities. Well, here, the probability, they're both the same, so I guess not much of a probability to calculate there. But here, it gets a little bit more interesting. We want the value to be between a half and 1. The probability of that is a half. We want here the probability to be between a half and a 1. So that's half the numbers, basically, of our range. So another half. Then we have to multiply those. X has probability of a half, y has a probability of half, and that's a quarter. All right, so that is how we're going to produce the probabilities, and in the end we have to add up all the probabilities, and I have a feeling it's going to be an infinite geometric series, and I know that because I've done a lot of these questions. I can kind of read their minds. But let's keep going. Okay, for now, -2. Same story. Log of -2. X to the base 2 is -2. So that means 2 to the -2 is x, and therefore x is 1 over 2 to the 2, which is a quarter. So now x has got to be less than a half, but it's got to be greater than a quarter, greater than or equal to. And similarly, y has to be the same, in the same range. Okay, so now let's figure out the probability. Again, that's about a quarter of the values of our full range. So the probability of getting y is a quarter. This again is a quarter of the full range. So again, a quarter. You have to multiply them. You get 1 over 16. Let's just do one more, and I think that should be sufficient. That's when we have -3. So log of x to the base 2 is -3. So that means 2 to the -3 is x. And therefore x is 1 over 8. So that means x has got to be less than a quarter, but it's got to be greater than or equal to 1/8. And similarly, y has got to be less than a quarter, greater than or equal to 1/8, and that's for -3. And now let's figure out the probabilities. A quarter to an eighth is approximately, well, 1/8 of all the values from 0 to 8, right? Yeah. So the probability of getting a y is an eighth, the probability of getting an eighth, x is an eighth, and when you multiply them, you get 1 over 64. Okay, exactly what I thought. Now when we add up these probabilities, it's gonna keep going, right? Dot, dot, dot. So it's basically 1 over 4 plus 1 over 16 plus 1 over 64 plus dot, dot, dot. Keeps on going. And we know that formula, a over 1 minus r, sum of an infinite geometric series. A is the first term. In our case, it's a quarter. R is the common ratio. You get the common ratio by dividing the second term by the first term. And that is 1 over 16. And invert and multiply 4 over 1. And that's 1 over 4. So R is 1 over 4. So we have 1 minus a quarter. So this is a quarter over 3 quarters. So 1 over 4 times 4 over 3. And that is 1 over 3. There we go. 1/3 is the answer to this question. Number 20 is D.